Hey guys, Professor Calculus is here, and today in this video we're going to solve a really interesting integral that involves digamma functions. Now first of all, what are digamma functions? So, if you know gamma functions, I don't remember the definition of gamma function right now in my head because we don't need it actually for this video. This integral is more abstract, but gamma function is actually defined as an integral of some two parameters. And the digamma function, denoted as psi of x, is defined as gamma prime of x over gamma of x. So, how should we solve this integral? So first of all, let's remind ourselves that Euler's reflection is defined as gamma of x, gamma of 1 minus x, to be equal to pi cosecant of pi x. And now let's take the ln of both sides to see what happens. Ln of gamma of x, gamma of 1 minus x is equal to ln of pi cosecant of pi x. And now I can, according to the properties of logarithms, if I have a product of inside a logarithm, I can expand them like ln of gamma of x plus ln of gamma of 1 minus x is equal to ln of pi plus ln of 1 over sine of pi x, and here we have a negative power, sine of pi x to the power of negative 1, and I can write it as minus 1 over minus ln of sine pi x. And if I now take the derivative of both sides, taking the derivative of both sides of these two things would give me, if I take the derivative, this would give me 1 over gamma of x times gamma prime of x according to the logarithms derivatives, plus 1 over gamma of 1 minus x times gamma prime of 1 minus x equals to the derivative of a constant is 0, and the derivative of ln of sine pi x is equal to 1 over sine pi x times pi cosine pi x, and therefore gamma prime of x, gamma of x plus gamma prime of 1 minus x, gamma of 1 minus x is equal to pi cotangent of pi x. Now let's remind ourselves of the digamma function, which is defined as psi of x equals to gamma prime of x, gamma of x, and psi of 1 minus x equals gamma prime of 1 minus x over gamma of 1 minus x. See how these are too similar? So this is psi of x, and this is psi of 1 minus x. So we concluded that psi of x plus psi of 1 minus x is equal to pi cotangent of pi x. And our integral psi of x minus psi of 1 minus x dx would then, sorry, this was supposed to be negative pi. I forgot a negative here because there was a negative here. So so this integral here would become then the integral of negative pi cotangent of pi x dx. And now, oh sorry, I forgot one thing also. This should have been negative here because according to chain rule, we're taking derivative of a gamma function here, and we gotta multiply by derivative of this chain, which is -1. So this, we should have had negative here. That's why I hesitated a little. So this should have been a negative here. So it is equal to negative pi cotangent of pi x dx, which is equal to negative pi cosine of pi x over sine of pi x dx. And then let u to be equal to sine of pi x. du is going to become cosine of pi x times pi. And I therefore would be equal to negative would be equal to integral of negative du over u, du over u, which is equal to -1 of u. And if I replace it, would be -1 of sine of pi x plus c. Therefore, our integral digamma of x psi of x minus psi of 1 minus x is equal to -1 of sine of pi x plus the some constant of integration, and that is the final form of our integral here. Hope you enjoyed this video. Please like and subscribe, and I'll see you next video.